today we will start, that was me, yeah. And today we will start with a keynote, the introduction into the world of the Einstein telescope by Professor Dr. Achim Stahl from the RWTH Aachen University. He will give us an overview about the technologies and the cool things you can do with this. So thank you, and the stage is yours.
Okay, so here are the slides. So if you ever thought about what is out there in the universe, where it came from, how it's developing, then you're right here, because that's what it's all about. Understanding of where the universe comes from, how it evolves, and where it's going to go. And the Einstein telescope is a fantastic new telescope in order to explore this universe and to learn about all its details. Out there are spectacular objects, for example, like black holes. What you see here is the first picture of a black hole ever taken. Now, the black hole itself is the black dot in the center. It's where you see nothing because you cannot see black holes. But what you see is the disturbances of space and time around the black hole. This picture was taken by the Event Horizon Telescope. It's a radio telescope, or actually a combination of a lot of radio telescopes that have managed to make this picture a few years ago. Also, the Einstein telescope looks at black holes, but in a slightly different way. We're looking at black holes that are spiraling around each other in double star systems. So if they spiral around each other, they periodically disturb space and time. They shorten and lengthen space components. And this periodic change travels out from the source through the universe. It can travel for millions, even hundreds of millions of years undisturbed through the universe. And at some point, it might reach Earth. And if it reaches Earth, it will shorten and lengthen the Earth. The Earth will start to wobble. And that's the effect of the gravitational wave that we can detect with the Einstein telescope. Now, what happens is the Earth wobbles, and on the Earth, we have the Einstein telescope, which is essentially a combination of Michelson interferometers. So when the Earth wobbles, the Michelson interferometer will wobble too. So periodically, one arm shortens, the other gets longer, and vice versa. And this we can detect with the Einstein telescope. The fascinating thing about it is the sensitivity, because of exaggerating the effect. The Earth is not wobbling that much. It's just wobbling a tiny little bit. And the tiny little bit is this. This is the sensitivity that we've actually achieved with the current telescopes. And with the Einstein telescope, we will get a factor of 10 better. Now, the number is so small that I can't even read it out to you. So this is the change of length in one of the arms of the interferometer that we can detect. For reference, this is the wavelength of the laser in the same units. This is the size of an atom in micrometers, an angstrom. So you can see the sensitivity is much better than the size of an atom. If such a mirror moves by the diameter of an atom, it would create a gigantic signal in the telescope. This is the size of a nucleus, factor of 10,000 smaller. And this is the size of a proton, another factor of 10 smaller. And you can see the sensitivity is still better than the size of a proton. And I guess the reason why you are here today is because you might want to join us in developing the technology that is behind this, the technology that enables us to measure such tiny little length changes. In order to do that, let me first explain how the Michelson interferometer works. So it's a laser which hits a beam splitter in the center and divides its beam into two passes. Those two passes travel out to the end mirror and are reflected back. Remember, light is an electromagnetic wave. It has hills and valleys. And when the two beams come back, they reunite at the beam splitter and they overlay. And if the valley of one beam falls onto the hill of the other, then there's darkness on the output. And it's exactly how we operate the interferometer, darkness on the output. If then a gravitational wave comes and moves the mirrors, this is no longer the case. And then we suddenly see light on the output. And we see the light on the output with proportional to the amplitude of the gravitational wave. That's how we detect it. Now, the game is now twofold. We have to increase the signal and we have to decrease the noise. We first spend a few minutes on how we increase the signal. This is again the Michelson interferometer, beam splitter B in the center, the two end mirrors M1 and M2. LD is the output sensor and LS is the laser. Now we can enhance the signal by putting another mirror here between the beam splitter at the beginning of the arm and the end mirror. This will lead to a reflection of the beam forth and back. In fact, it goes forth and back approximately 10,000 times before it goes back to the beam splitter and reunites with the other arm. And every time the beam goes forth and back once, the shift in the phase increases slightly. So this gives us a factor of 10,000 in the sensitivity. Now you might ask yourself, if we are tuning the arms such that there's darkness on the output on the photodetector, then where does the light go? Well, there are actually two outputs on the interferometer. One is towards the photodiode and the other is towards the laser. So if you tune the photodiode output to darkness, it means that all the power of the laser goes back to the laser and is wasted. So we can put another mirror there and send the light back into the interferometer, increasing the power in the interferometer. It's like turning the whole interferometer into a resonant cavity. So in the case of absence of a gravitational wave, this is actually the optimal you can do. If there is really a signal, then you can do one step more. You can also put another laser on the output and multiply the output signal that we see by the signal recycling mirror. So that's the final configuration. And now the only parameter that's left to increase the signal is the length of the arms. The longer we make the arms, the larger is the change of the length due to the gravitational wave, and that directly improves the sensitivity. And for the Einstein telescope, we want to go to 10-kilometer long arms. Okay, so this is what we can do in order to increase the signal. So the second thing we can do is reducing the noise. All the artificial changes of length of the arm cavities, vibrations of the mirrors, movements of the mirrors, all these things. And here you see the noise curves. First of all, you see two. You see two because each gravitational wave detector for the Einstein telescope, there will be 3 of those detectors, is composed of 2 interferometers. One, that's the one on the left, optimized for low frequencies. And you can see on the horizontal axis, you can see the frequencies. And you see the low frequency interferometer has its optimal sensitivity around 10 Hertz, while the high frequency one on the right side has the optimal sensitivity around 200-300 Hertz. Yeah? So on the horizontal axis, you see the frequency of the signal. And on the vertical axis is the strain. The strain is just the relative change in length of the cavity. So 10 to minus 23 means that the cavity length has been changed by 10 to minus 23 times 10 kilometers. That's the absolute length, change of the length. The sensitivity is given by the solid black line. Any strain that is above the black line can be detected. Any strain that is below the black line will be hidden in the noise. And the colored curves, they give you the composition of the noise, the different sources of noise. Now that's a very complicated science and technology, all those noise curves and features. And I thought I'd pick out 2 of them and explain them to you. And I wanted to start by telling you something about the quantum noise. This is the pinkish curve, and you can see that it's the limiting factor at higher frequencies. For example, if you look at the right side, at the higher frequency interferometer, you can see above something like 400-500 Hertz, the sensitivity is completely dominated by the quantum noise. And the loss of sensitivity indicated by the racing curve is entirely created by the quantum noise. So what is quantum noise? Go back to the picture of the interferometer. So in the center is this beam splitter. The beam splitter splits the beam into two equal parts. If you look a little bit, think about a laser beam, you can also think about it as a beam of photons, little units of electromagnetic light. And for a laser power of a kilowatt, you have in the order of 10 to 22 photons per second. Yeah, that's a very huge number. And they split up into the intensity of the two beams. Now, but even at this very high statistic, there are statistical fluctuations. So once in a while, a few more photons will go left and a few less will go straight. And then when the beam comes back and is overlaid with the other beam, the destructive interference is no longer perfect. And you will see fluctuations on the output, which are proportional to the statistical fluctuation of the number of photons in the laser beam. This is called the shot noise. And as it always is the case in large number statistics, Gaussian statistics, the relative fluctuation, which is relative here, decreases with 1 over the square root of the number of photons. So if you want to reduce the shot noise, what you can do is you can go up with the laser power. The more power you have, the more photons you have, the less fluctuations. But there is a second effect. Now, if the photons hit the end mirror, they will push away the mirror a little bit. This is called radiation pressure. So each photon has to be deflected from the mirror into the opposite direction, carries a momentum, and when the momentum changes into the opposite direction, force is exaggerated on the mirror, and the mirror will start to move under the impact of the reflected laser beam. Now, this is not a problem because we can correct for that. Yeah? But the problem is, if the laser intensity fluctuates, if the number of photons fluctuate, then also the radiation pressure fluctuates. And the fluctuations we cannot compensate. But in this case, it's not about the relative uncertainty in the number of fluctuation. The variation in the radiation pressure goes with the absolute fluctuation. So it goes with the square root of the number of photons. So if you go up with the laser power, the radiation pressure increases, and at the same time, the fluctuations of the radiation pressure increases, and that reduces again your sensitivity. So between those two, you can find an optimal laser power, and this is called the standard quantum limit. And you can calculate that, and the change in length that is created by these two quantum effects is given by this formula here. There is a square root, there is an h bar indicating that it's quantum physics. In the denominator, delta t is the measurement interval. So if you're, for example, sampling with 10 kilohertz, then this would be 1/10 of a millisecond, the delta t. And at the bottom is the only parameter that you have to control that. It's the mass of the mirror. So the heavier you make the mirror, the less influence has the radiation pressure. You can up. So if you double the mass of the mirror, you can go up a little bit in radiation power, get less radiation pressure and less shot noise. Okay. Yeah, and so this is how we do it. Then in the end, this is again the photograph of the sketch of the interferometer, and what we use for the high frequency mirror. This is the mirror where those quantum effects are most relevant. Is we use fused silica, 62 centimeter diameter mirror with a weight of 200 kilograms. That's quite a heavy object, and you can imagine that there's a limitation on how far you can go in mass. And the laser power is 3 megawatt. This is the laser power in the resonant cavities in the arm. The injection laser power is more in the order of a few kilowatt. This is the effect of the signal recycling mirror then. Okay, but on the low end, there is another problem, and this is called the thermal noise. And I want to show you what we do about that. So thermal noise, you know, thermal heat means that the objects are statistically moving. If you would take a microscope, which is good enough to see atoms on the surface of the mirror, you could see that all those atoms are moving around erratically. And the more they move, the warmer the mirror is. And this, of course, means that also the surface of the mirror is slightly fluctuating. And that creates noise. In order to get rid of that, there is only one way, and that means you have to cool the mirror. So you want to cool the mirror to 10 Kelvin in order to get rid of the thermal motion. But the problem is that we are reflecting a megawatt laser from that mirror, and the reflection is never perfect. There's always a slight amount of the laser power that is absorbed in the coatings of the mirror or even in the bulk of the mirror. And this is our typical numbers that you see there on the left side. So a few ppm are typical numbers. And for a megawatt laser, this is a very substantial amount of power, and it leads to heating of the mirrors. And it's very difficult to keep a mirror then at 10 Kelvin. It's actually not possible. And this is the reason why we built two interferometers. So the interferometer on the left, on the low frequency side, uses less laser power because the quantum fluctuations are not so important at low frequency, and therefore it allows us to cool the mirror to 10 Kelvin. So on the low frequency interferometer, we have slightly smaller mirrors, same weight, but we only have 18 kilowatt of laser power, and therefore we cool it down to 10 to 20 Kelvin. And we use silicon as a base material. And the reason is that glass has no longer suitable properties at those low temperature, while silicon actually does have. You see on the left side, you see the thermal expansion, coefficient of thermal expansion of silicon. And you can see if you go down to 10 Kelvin, it's essentially 0, which is very good because it means if you put the mirror, the beam on the mirror, and you heat the mirror essentially in the center, while on the outer circumference there's very less laser power, then you don't create stress. You could create a temperature profile, but not stress. On the other hand, on the right diagram, you see the thermal conductivity of silicon, and you can see that it's reasonably good even at 10 Kelvin in the order of the conductivity of copper, which allows you efficiently to transport away the heat that you're injecting. The downside is that silicon, as you probably know, is not transparent for visual light. And at least the beam splitter, the laser beam has to go through. So that doesn't work. And the way out is to go to longer wavelengths. What you see in this diagram is the absorption coefficient of silicon as a function of the laser wavelengths. And you can see if you go down something below 1.4, 1.5 micrometers, then silicon becomes transparent. Which means that we have to develop completely new lasers, completely new optics, and everything that is necessary to operate at these low frequencies. Okay, so this is two of those curves that I've explained to you, and I think I'm running out of time. Therefore, I will not go into all the other curves. Instead, I want to summarize the Einstein telescope. So what we're trying to build is a triangle underground. We want to go underground because in the solid rock underground, the vibrations that come from the surfaces are damped, and we don't have problems with surface waves, with seismic surface waves. That's the main reason why we go underground. We build interferometers with 10-kilometer length. We want to have more than one, because those interferometers, I did not explain that to you, but they're only sensitive to certain directions. In order to get a reasonably uniform sensitivity in all directions in the universe, you need at least 2, better 3 of them. And if you want to build 3, if you combine them into a triangle, then we minimize the number of tunnels that we have to build. So therefore, there in each corner, there is one detector, which means 2 interferometers. So in each corner, there's one beam splitter for the low frequency interferometer and one beam splitter for the high frequency interferometer. And the 2 arms are going out into two possible directions with a 60-degree angle. The low frequency interferometer will be cooled to cryogenic temperatures. The high frequency one will also be cooled slightly, but not as low. In order to further reduce the vibrations and the seismic disturbances, the only remaining parameter you have is to find a quiet location. And Meusrin is actually a very quiet location with a special geology that is particularly suited for the Einstein telescope. I think that's all the relevant points. Thank you for listening.
Yes, Professor Stahl, sorry. Thank you very much for this interesting introduction to the Einstein telescope. A question can be asked after the talks again. So next, now we know why we do need an Einstein telescope. Now we can get more into detail about how can we get the Einstein telescope. For this, I think Ralf Meyer will present the project ET2SMEs, which is one of 3 projects in the Regio Meuse-Rhein. It's ET Pathfinder, ETS, and ET2SMEs. I think the special thing about ET2SMEs is that we focus on the industry. So, Ralf, the stage is yours.
Yeah, thank you, Henrik, and a special thank to Achim Stahl for this excellent presentation. It's always a pleasure to hear you talking about the Einstein telescope. First of all, what I want to say is that I want to give all a warm welcome on behalf of the ET2SMEs partnership, and also, of course, from my side. We are very pleased to have more than 100 registrations to our today's event. And yeah, it's really a very good resonance to this online meeting, which we organized on very short notice, especially due to the COVID pandemic. Yeah, you see my name. You see that I'm from the Regional Development Agency of Aachen region, and we are leading the ET2SMEs project. The next slide, please. So what I want to do is to briefly elaborate on the targets, on the offers, on the added values for SMEs. And looking at the audience today, more than 2/3 of us are SMEs, and that is exactly the target group we are going for here with this project. What you can see here is that was already mentioned by Hendrik, that we have already various projects, various activities going on in this cross-border region. Although the location decision for the Einstein telescope is not taken so far, so this will be end of 2024, beginning 2025. Although this decision is not taken so far, our cross-border area is already substantially investing in this new cutting-edge infrastructure for the future. We have in total already amounts of around about 45 million euro that are spent or will be spent until the end of 2023. And what you can see here on this slide is that we have 3 especially cross-border projects. I just want to mention them briefly so that you can or that you are aware of what is going on. We have on the left side the ET Pathfinder project, funded by the region from Flanders and the Netherlands, which is about a model, a pilot infrastructure realized in Maastricht, where all the basic technologies of this huge facility are explored and are tested. A project around about 14.8 million. Then we have, as a second project here in the Regio Meuse-Rhein, the ETEST project, which is especially focusing, as you can see from the pictures, on the one hand, doing the geological exploration, so meaning that there are around about 30 boreholes here in testing, in looking at what are the conditions at the underground here for this huge facility. And we also have various core technologies which are developed, like Achim Stahl already presented them. It's a project led by the University of Liège and around about 15 million. And now we, our project partnership, the ET2SMEs partnership, well, we are the youngest project amongst those three project activities. We are running since March of this year, and our project is especially about the promotion of the cooperation between SMEs, large companies, and also R&D institutions that all deal with Einstein telescope technologies, but in a broader sense. Our project is running until 2023, and looking at the partnerships that are behind these projects, please the next slide. You can see that we really have a huge community already who is dealing with the Einstein telescope here in this cross-border region. Especially this overview shows how many research institutions especially are involved. So the whole who is who of the Dutch, Belgian and North Rhine-Westphalian area in research is really represented here. The next one. Looking at our project ET2SMEs, so in the first row you see our partnership across this Euregio-Meuse-Rhine region, but we are very pleased to be supported also by various associated partners from the enlarged region of Belgium, the Netherlands, and North Rhine-Westphalia, and also we have various partners supporting us with a letter of intent. So it's very important for us that this task of involving SMEs is shared with other institutions and promoted also by other institutions. The next one. So if we look now at the project scope that we have in ET2SMEs, well, it's always talked about the key enabling technologies in European, but also in global sense. And if you look at the Einstein telescope, at least 5 of the 6 key enabling technology that are very relevant for future development are represented here in this infrastructure. Only biotechnology is maybe not amongst them. And what you can see, please click 2 times more, is here's the black ones are the instrument technologies that are relevant for running the Einstein telescope, and in red you see also the geology technologies, all issues dealing with the underground, with the planning, with the building, with the exploration of this facility. And what we want to do with our project is, please click several times more, is that we look at these enabling technologies with a great impact on various applications field. And as I already said, we are not only pointing out to the astronomy part of economy, but we are also looking at neighboring fields like aerospace, like automotive, and also further demanding application fields. The next one. So this is in a nutshell, in one picture, what we are offering via ET2SMEs. We start with the mapping, we start with company visits and networking activities, and we end up in innovation projects and activities for sustaining, for really allowing a soft landing of this huge infrastructure here in this cross-border region. So what I will do now is, please go to the next slide, is to go from this in a nutshell overview through all these opportunities that you as an SME really have within this project. So first of all, if we engage for such a huge facility, we have to create something like an Einstein community. And therefore, we really do this mapping exercise. So here you see in a picture displaying this underground infrastructure, displaying the main technologies that are relevant for this Einstein telescope. And what we establish all over the extended Euro-Meuse-Rhine and probably also the other parts of Belgium, the Netherlands, and North Rhine-Westphalia, a new mapping tool where we really can mirror the expertise, the competencies that is available in this cross-border region. Please, the next slide. So here you can see such an info profile. We are building already at this community so that each company, this is an example from an Aachen region-based company, that each company, but also each research institutions from this area can be visible on this platform and can gain international recognition in the whole area of the Einstein telescope. The next one. What is then also important is that we do company visits, that we do networking activities, and just to step in, the next slide please, into the company visits. What we already do is really go for one-to-one meetings with most of the relevant companies here. And what you can see here from this slide is our activity, or one of our main activities that we did. So we already have visited with our partnership around about 150 companies all over this cross-border area. You can see on the left side the various regions where we did these interviews and visits, and on the right side you can see looking at this target groups at the companies in which technologies these companies were already active in. So this is still an important part. And what we also do, the next slide, is that we visit important events, congresses, where we really promote also what we are doing within the project. Here, just some examples. The next one. What we also do, we will come back to that later in the program, that we will arrange in spring. We will arrange technology workshops with keynote speakers, the core researchers active in Einstein telescope technologies, where we give companies the opportunity to pitch their business, but also their ideas, and where we will also allow company matchmakings. The next one. And of course, if feasible, we will do also lab tours, facility tours. So that is one of the also very crucial parts of what we offer. The next one. For today, we have named this event the Innovation Voucher Kickoff, and therefore these innovation vouchers are very important. What do we offer in this regard? The next one. First of all, you have to step, of course, if you want to be part of the community, you have to dive a little bit deeper. You have to look at the various needs, the development needs within the Einstein telescope technologies. And on our website, ET2SMEs, you can find here this ET technology online catalog with all the requirements, with all the needs, with all the developments that have to be made. You can see here, and I can only advise you to take a look at our website and really step into the key challenges that we really are facing here with these technologies. And then, of course, also get in contact with the researchers and get in contact with us if you really have an own project idea in this context. The next one. We are supporting this via innovation vouchers with amounts up to 50,000 euro. I will leave that out because my next speaker, René Kessen, will explain and elaborate more about what we are doing within this innovation voucher scheme. The next one. And to finalize my speech, what we also are thinking of, I mentioned it, is that we want to create a community, that we want to have an ongoing industrial advisory board for the Einstein telescope that really can be used as an exchange and also as an advice platform for the next decades, for the next years. And therefore, this is also a very crucial part of our activities of all three projects that you see here, that we really are building constantly on this partnership of the advisory board, which will meet 2 times a year in order to support also this exchange and community idea. The next one. I will close now my speech with a very short remark on the information. I mentioned the website, so I think it's very important for you that you take a look at our website with all the information, especially also on the innovation vouchers. I would like to say, please, the next slide. Thank you for your attention, and see you or hear your ideas in the next period in the future. Thank you.
So thank you very much, Ralf, for your introduction to ET2SMEs. Now, as you already mentioned, the next presentation, it's my pleasure to introduce René Kessen from LIOF from the Netherlands. He will give us an insight into the voucher scheme. So, René, the screen is yours.
Yes, thank you very much, Hendrik, and thank you very much, Ralf, for the introduction already. I'm very happy to be able to elaborate more on the voucher scheme and explain to you all the great possibilities that we have to offer to the SMEs in this region in this voucher scheme. Let's see. Now, the goal of the voucher scheme is very simple. It's expressed in one line, is to stimulate the SMEs to innovate by not just offering financial incentive, but also offering, as a start, business development support. And now, as already indicated by Mr. Ralf Meyer, if you have a project idea about innovation, then let us know. And we have a wonderful team of experienced business developers from all the 4 regions in the EMR region. And those business developers can help you with formulating your project, finding suitable partners in the region, help you with the application. And so in general, a lot of business development support available within this region by the project members. Now, beside the development support, and not really unattractive, is the financial support that this voucher scheme has to offer. As you all know, doing innovation is related to some financial risks, and the goal of this voucher scheme is to lower a bit the financial risk involved with innovation. And the total budget that we have in the voucher scheme is 450,000 euros, and is completely funded by ERDF, which is the European Regional Development Fund. Now, beside the development support and the financial support, what's also important and really valuable in this project is that we can offer you the excellent opportunity to cooperate and co-create with partners within the regions. We have a lot of experience, a lot of knowledge, a lot of competence in the region. And this project, this platform, and the voucher scheme offers you to cooperate as a company with universities, with R&D institutes, and with other companies within the region Meuse-Rhine. Now, the word region Meuse-Rhine is already mentioned quite often. I just want to elaborate more on, okay, when is your company established in the region Meuse-Rhine? And we also have an extended region Meuse-Rhine, because the project not just aims for, say, the core, the region Most Rhine, but we have an extended area. And the extended area consists of a few regions. Now, first of all, in Germany, it involves the regions Aachen, Limburg, Prüm, and Vulkaneifel. In Belgium, we have the regions Liège, Limburg, and Leuven. And in the Netherlands, finally, we have the regions Zuid and Midden-Limburg and Brainport region Eindhoven. So this is, let's say, the key area, the target area of the project and also of the vouchers. Now, the first question you might have is, when can I apply for this voucher? Now, the ones that can apply for this voucher is what we call a cross-border cooperation consortium, because we will not only want to stimulate innovation, we also want to stimulate innovation in a cooperation cross-border. Now, the minimum requirement for a consortium is that there are 2 technology-oriented enterprises located in different countries cross-border area, in the extended Eurasian Most Rhine, so a German company with a Dutch company or a Belgian company with a German company. And at least one of these enterprises is an SME. So the other enterprise located in the extended Eurasian Most Rhine can also be a large enterprise. So minimum requirement, 1 SME in that cross-border consortium. Now, additionally, besides this minimum requirement, also other enterprises can join. And this can be an SME or a large enterprise. The companies or the institutes can be located inside or outside the extended region, Most Rhine, and it also can be a university or a research institute. Now, when can you apply for a voucher? Now, the goal of the voucher is to stimulate innovation, and innovation, we're talking about an innovation project. And that is where you and that partner and possible other partners in the consortium are going to develop an innovative product technology. This product or technology is new to the firm or new to the market. It's relevant for the Einstein telescope, but not just only relevant for the Einstein telescope, it can also be relevant for other markets beyond the Einstein telescope. For example, if you're talking about the reduction of vibrations or thermal isolation, that is not just relevant for the Einstein telescope, it's also relevant for other markets like the semicon or the quantum computing. So it's not just about the Einstein telescope, the technologies and the products can also be applied in other markets beyond Einstein telescope. Now, as Ralf Meyer already indicated, when is the product relevant for the Einstein telescope? And that is if the product or the technology is based on the technologies that are relevant in the Einstein telescope. We have 2 technology domains. One is really the instrument, the Einstein telescope, and the other ones are related to all the geology. Now, more details about the technologies can be found on the website ET2SMEs.eu. And as Mr. Meyer already said, we advise you to look at the technologies, open the sheets and look at all the details, the challenges in the Einstein telescope context, and also the possibilities to develop technology and develop products for other markets. Now, what does the voucher contribute? What's really important to mention is that within this project that you're going to realize with the partner, before you do this project, and that is also part of the application, is that you define clear, tangible, and provable deliverables in this project. Because the realization of these deliverables are really, let's say, almost the only condition to be able to receive the voucher in the end. And now the partners in the consortium that are able to profit from the voucher are the SMEs that are located within the extended region. So to be clear, other companies, large enterprises or SMEs outside the region, Mees-Rijn, or R&D institutes, universities, they can also join the consortium. They can be partner and they can profit from possibilities that this innovation project can offer, but only the SMEs located in the extended region Mees-Rijn, they can actually profit from the financial incentive that this voucher scheme is to offer. And as I mentioned earlier, if you realize the deliverables at the end of the project, and you can prove that you realize the deliverables, then the voucher will be paid as a lump sum value. Now, the contribution of the voucher is 50% of the project costs that are necessary to realize the deliverables, 50%. And of course, we have a maximum, and the maximum, there are two possibilities. If there is a consortium that has one eligible SME, then the maximum voucher value is €25,000. And if the consortium consists of more than one eligible SMEs, 2 or more, then the maximum voucher value is €50,000. So 50% of the costs with a maximum of either €25,000 or €50,000. Now, when can you apply? Let's say the epicenter of the voucher scheme is, let's say, mainly in 2022, which is next year, of course. Now, we have several calls in 2021 and 2022, and these calls will be approximately every 2 months. Each call has an opening date and a closing date. Now, the first call that we have opened the 1st of December and will remain open until the 24th of January 2022. So within this time frame, you can apply for a voucher. The second call starts on the 31st of January and closes on the 28th of February. So we have approximately 2 months opening for the first call, and then after that, approximately a month for the second call. Now, we have more calls in 2022, but it's very important to highlight that there will be calls as long as there is budget. So don't procrastinate, don't shift your project idea to next year, because it could happen that the budget is already not available anymore. Now, how does it work? Now, as a first step in gray, what I mentioned earlier is the preparation of the application. So if you have a project idea and you want to, let's say you have plans to innovate, to develop a product or technology, and you're looking for a partner, the business developers in your region can support you with finding a suitable partner cross-border, help you with defining the project, also help you with setting up the application for the voucher scheme. So you really don't have to do it on your own. There's a lot of expertise available within the project team to help you with the project, business case, and the application. Now, if you've defined your project and you have set up your application, then the first step is to apply. Now, as already mentioned, we have several calls where you can submit an application, and the application consists of 2 forms. The first form is the application form, where you introduce yourself, where you introduce your partners, where you describe the product that you want to develop, and where you also elaborate a bit on the business case behind the product, and where you define the project plan and the deliverables that we mentioned earlier that have to be realized within the project. The second form is a self-declaration form. The self-declaration form consists of 3 parts. First part is a statement with regards to the de minimis state aid regulations. The second part is, let's say, the confirmation that each of the partners that want to profit from the voucher is indeed an SME. And the third thing that we want to check is that the SME that wants to apply for a voucher is not in trouble. And in trouble, I mean financial trouble. Now, after you have submitted your application, the application is checked. We call this the eligibility check, just to make sure that the consortium and the project fits within the regulations of the voucher scheme. Now, once the application is eligible, then the next step is the actual assessment of the application. And for that, we have an assessment committee, on which I will elaborate in a few slides later. And the application is assessed based on a few assessment criteria, which we also based on the scores of this assessment, you will either be awarded with the grant or either be rejected. And in the latter case, there is still an opportunity to reapply with an improved application one more time. Now, once the application is approved, then it's really up to you, your partner, to the consortium, to realize the project and specifically to realize deliverables mentioned and defined in the application. And the lead time to do this is a maximum of 9 months. Now, what's really important to keep in mind is that since we have a fairly limited runtime of this project, we also have an ultimate end date of the voucher schemes. And that's also really an ultimate end date where all the projects have to be ended, because we still need some time to complete and finalize the voucher scheme administration. Yes. Now, if you have completed the project and specifically realized deliverables, then the last stage is to fill in a final evaluation form where you briefly summarize the project and where you also confirm whether the deliverables have been realized in this project. Now, this will be proved by the project partners of the region, and if the deliverables are indeed met, then the voucher contribution will be paid to the lead SME. The lead SME will distribute the shares and parts to the other eligible partners in the consortium. Now, to elaborate more on the assessment criteria, there are 4 assessment criteria, and each of those 4 has an equal value in the total score. The first criterion is the level of innovativeness. And that's what we call the level of innovation and all the innovative results that are expected out of the proposed activities. The second criterion is the market. This is, let's say, the level of the market-oriented cooperation and the market potential of the innovative product, not just potential for the Einstein telescope, but also the potential for other markets. The third criterion that we will assess is the high-tech character. This is the level of technology, which is the basis for the project, but also the connection with the Einstein telescope technologies. The last criterion is about the economic and the regional impact. So the economic impact, not just for the company, but also the economic impact for the region, Meusrhein. Now, on all of these criteria, the application will get a score. And the scores that will be given can vary between 0 and 4, where 0 most logically is insufficiently, and you will get a 0, like in the early days on school, where you have not filled in the application completely, where the criteria are insufficiently described and are not accessible, or whether the information provided is not sufficiently substantiated. Now, we assume that this will not be the case because we will support you with the application. Now, the score level that we want to see in a project is between 2.5 and 4. So meaning the edge between a moderate score and a good score up until a high score. And that is really quality level that we want to see in this project. Now, this number of 2.5 is very important because if you look at the assessment score, I mentioned we have an assessment committee, and the assessment committee consists of 3 groups, and each group has 2 people in it. Now, the first group is a representation of the ET2SMEs project partners. And those are the project partners from the regions that are not involved in the project. So, for example, if we have a German-Dutch consortium that applies, then the project partners of Flanders and Walloon will do the assessment on behalf of the project team. Now, the other 2 groups, those are external experts. And we distinguish business experts that focuses on the business case behind the product. And we also have technology experts that focus more on the, let's say, the level of technology and also the link to the Einstein telescope. And the same as with the project partners, the business experts and the technology experts that assess an application are from the regions that are not involved in the project. So in the example of a Dutch-German consortium, business experts, technology experts from Flanders and Walloon will do the assessment. And for this, to enable this, all the regions have found experts available and willing to support with the application.
We are a bit late.
Yes, I will speed it up. Now, the scores, if you put all the scores in the table, then for each criterion, you will have an average criterion score. And also you will have an overall average score, which is Y. Now, what is really important is that the average criteria scores, the X's, have at least an average score of 2.5. There can be one which is lower than 2.5, but they all have to be above 2. And the third requirement is that the overall average score is at least 2.5. And in that case, you will have a positive score. Now, I want to finish with an example on the scores. Going back to the example of the Dutch-German consortium, you see the scores here of the project partners, the business experts and the technology experts in Flanders and Walloon. Now, on the right side, you will see the scores, and you will see that there's one score which is lower than 2.5, and that's okay, as long as it's 1. And the overall average score is 2.5. So this application meets the requirements and will be awarded with the grant. Now, with this final slide, I would like to thank you for your attention. I hope the voucher scheme and the details are more clear. And of course, as Hendrik already mentioned, if you have any questions in the voucher scheme, I will be more than happy to answer the questions at the end of this session. Thank you, Hendrik.
Yes, thank you, René, for your talk. I would like to have a short interruption, if it's possible, just to have a to do the group picture. So, Matthias, if you could stop the screen sharing, and all of you, please activate your camera unless you don't want to be in the. Wait, I have to change. Yes, now I have it. Perfect. Okay. So I need to take 4 pictures. So and the first one, wait. We're too many for one screenshot. Okay, the next. Okay, and the last one. So thank you very much. And now we can go on with our program. So Matthias, you can start your screen sharing again, because next, now we know about the Einstein telescope and the possibilities in ET2SMEs. But now you might think about, there are so many networks involved into this project. So we have the next talk from Maxime Corvilain from the POM Limburg in Belgium about the project consortium, how to find a project consortium. Maxime, the floor is yours.
Thank you, Hendrik. Welcome, everyone. Just to quickly, I will not make it too long, but I want to show you how to start with a project ID for Einstein telescope. Let me check. Okay, so how to develop your ID project ID. So for the beginning, it's maybe important to mention that often companies or SMEs are afraid of the extreme specifications of Einstein telescopes, cooling to 10 Kelvin, ultra high vacuum systems. But the goal of these innovation projects is not merely to reach these Einstein telescope specifications directly, but to bring your technologies closer to that level. So the goal is to bring your technologies closer to the Einstein telescope, not only to already be meeting those extreme specifications. So we want to also stimulate you, that you SMEs get inspired by this Einstein telescope to test new applications for these technologies, or for your own technologies, to test them in more extreme conditions. And so we can bring you, companies can bring new products and services to the market. So what we try to do here in this project is to support the SMEs and the companies by defining a project IDs and a 5-step model. Then we will support you by matchmaking. So we will find suitable partners for you if you need that support. And then we will help you by with the R&D project, how to submit it into a real voucher request. So this 5-step project ID, the first step that is of course very important is how relevant is your ID for the Einstein telescope. So already René has explained very well which kind of technologies are required. You can also take a look at the website. The second important thing is that you describe your project ID. Then how innovative is your project? That's also very important, because we already realized with some IDs that there has to be a knowledge gap. So you have to do something really innovative and not already offer an existing service. That's very important to have your voucher request granted. Also a small explanation of how your company is. What is your business model? And of course, maybe the most important for us business developers is that you mention how the ideal R&D partner should look like. Okay, what is the expertise that I require from another partner to bring my own product or service of my ID to a next level? That's in this short. So we start with this project ID. So we went to visit a lot of companies, and some companies already have some nice project IDs. So we asked the companies to fill a short description of this ID in the 5 steps that I just mentioned. Then what we do in the project is that we have internal business development meetings with the partners from the different regions, such as LIOF, AGIT, Skywin, and POM Limburg for the 4 different regions. And we sit together and try to couple these ID generators with relevant partners from the other regions. So really to set up cross-border corporations. So we try to do this matchmaking. Of course, we will always give potential partners and the the business that has suggested the ID can already can choose which one they want to cooperate with. And so in this way, we can really stimulate this consortia building, and that you can find each other much easier to request a voucher for an R&D project. So our role as the ET2SMEs partners is to help you form this consortia. So if you want our support, just ask us. So the time frame for now is normally we would have very nice technical workshops to give companies more concrete information about the Einstein telescope technologies. Unfortunately, we have been delayed a little bit by the COVID-19 crisis, but now we have another time frame from 2022 that we will organize 2 more info sessions in the months January and February. One more about instrument technologies and another one more about geological technologies, where you can have more information about how other technologies are working, how can I recognize myself as an SME in this science, in this technology side. Also some more information about the tenders, and that we really will have these 6 workshops in the month of April, May and June. And every month we will have 1 instrument workshop and always also 1 geological workshop. So we still have these 6 workshops planned. We don't have concrete dates set yet, but they will take place in the months of April, May, and June. So one will be more about the precision mechanics sensors and advanced control algorithms. The other ones will be about optics, mirror codes, and lasers. The geophysical imaging and simulation modeling as well, vacuum and cryogenics. So we'll always try to make 1 workshop about instrument and another one about geology. Also very important to mention is that we have a specific workshop, number 6, where all other technologies that are maybe underlying on the Einstein telescope that are required, such as data centers, such as sustainable energy provision. So this workshop will be organized probably at the end in the Netherlands. And then I would like to give the floor to the companies so they can give an example how to create such an ID.
So thank you very much, Maxime, for the presentation. I think next, who's exactly next? Our video presentation or?
Our video, yes.
Okay, so good luck, Matthias.
Welcome to our presentation on flexible roughness measurement device. fionec ET2SMEs project idea pitch. Herewith I would like to give you a short overview about our company. fionec was founded as a spin-off of the Fraunhofer IPT in 2007 and is based in Aachen. We are experts in fiber optic manufacturing metrology, fiber optic sensors and probes, measurement data processing and evaluation, development of algorithms and software. In addition, we are a distributor of Corning optical fibers, specialty and optical divisions. fionec regularly collaborates with partners from the business and academic communities on R&D projects. Current R&D partners are, for example, RWTH Aachen, Fraunhofer IPT Aachen and the University of Kassel. Our product portfolio is divided into the following 4 areas. Sensors and measuring systems. This area includes our fiber optic distance measuring systems of the FDM series, which use high-precision sensors for contactless distance, shape and roughness measurements with a resolution in the sub-nanometer range. In addition, the RMP surface roughness measuring station is based on a high-precision fiber optic measuring system for standard-compliant evaluation of roughness parameters. The design and manufacturing of fiber optic measurement and illumination probes belongs to the category of fiber optic probes. Within the software section, fionec offers specially developed control and evaluation software, for example for straightforward 2D display and processing of large data series, such as data viewer. Within the fiber optics sector, Fionec offers the complete portfolio of Corning's optical fiber and specialty fiber divisions, as well as corresponding accessories. Whether fast, contactless industrial technology or professionally manufactured probes and optical fibers, Fionec offers a wide range of fiber optic solutions that can be adapted to customer-specific requirements. Our ET2SMEs project idea is the development of a new way of surface measurement that could be relevant for the Einstein telescope, the gravitational wave observatory. Our aim is the combination of fiber optic interferometry with accurate positioning hardware to gain a flexible surface roughness measurement device. Our project idea contributes to ET technologies fields precision mechanics and mechatronics as well as to sensors and optics and optical metrology. Possible development needs within the first field are quality characterization of ultra-precise parts. Parameters could be form, surface and roughness. Another need could be precision linear stages with outstanding motion characteristics. Possible development needs within the second field are highly accurate fiber optical interferometers, which could be utilized as control sensors, subsystems and position control units. The combination of fiber optic measurement technology, fionec, and nano-positioning, JPE, is the new aspect of our idea. The result is a new and innovative measuring device that allows the measurement of surface roughness. This device is characterized by the following features. Fast measurement speed, up to factor 10 compared to standard systems. Non-contact, non-destructive and wear-free probe, in contrast to standard tactile systems. Outstanding measurement flexibility due to special kinematic setup. No need for multiple different tactile probes. Our cross-border partner JPE and we are characterized by the following complementary competencies. Technology leadership, fionec, precision optical fiber measurement, JPE, precision engineering. Nanotechnology, fionec, nano measurement, JPE, nano positioning. Innovativeness, fionec, development and realization of customized measuring solutions, JPE, development and realization of customized high-tech systems and scientific instruments. Research and development, fionec, collaboration with business partners and academic communities on R&D projects, JPE, working in continuously different pioneering applications. AGIT took our project idea and identified possible partners and presented them via a short profile. We selected the most suitable partner. AGIT and Zenit then initiated and held a project meeting at our partner JPE in the Netherlands. Thank you for your attention.
Thank you very
Okay.
much. Next, we have a short pitch from Terranigma, if I'm right.
Correctly.
Okay.
Mr. Stahl,
Yeah.
those slides are yours.
Yes.
Thanks. Yeah, thanks. I'm Fabian from Terranigma Solutions. First of all, thank you very much for having us. I'm going to quickly introduce our company and also present our project idea. And yeah, a little bit about our story. You can see our 5 co-founders here on the left. Simon is with me here today. Our story actually begins about 5 years ago when our CEO, Miguel, started doing his PhD at the Institute for Computational Geosciences and Reservoir Engineering at the RWTH Aachen University. This is Professor Florian Wellman's institute. And they together created GEMPI, an open source software for 3D geological modeling that quickly became more popular, especially amongst the scientific community. And this kind of showed us that there was a lot of potential in bringing the scientific expertise from this institute to real-world applications. And with this goal in mind of using innovative ideas and technologies to tackle real-world challenges, we created Terranigma in March 2020. Next slide, please. So our expertise is around 3D geodata processing and the building of geological models. We are currently developing a cloud-based solution for this that aims to provide a platform onto which different types of experts can work together remotely, no matter where they are, in real time and across different devices, say a desktop PC, a laptop, mobile devices such as a tablet, but also innovative devices such as mixed reality, virtual reality, augmented reality. And an important point here is that we want to use the computational powers of the cloud to bring together field and office environments. That means that the experts can bring with them the digital models into the field, but the other way around, also very, very quickly integrate new observations from the field or underground settings, such as in tunneling, directly into our cloud so that they can be immediately inspected remotely. And coming from this institute, we also have a lot of expertise in the field of probabilistic machine learning, especially in the field of geosciences. Next slide, please. So building on our cloud platform, we have the idea that we could, in this context, try to work out a workflow for kind of an automated data pipeline that brings new data about the geological conditions at the tunnel phase very, very quickly to the office or to remote locations. And this would involve three main steps. The first one would be an ideally automated and very quick step of gathering 3D scans, such as through photogrammetry at the tunnel phase. The second step would be to geospatially reference this new data and upload it to our cloud platform. And then the third phase would be that over this cloud platform, make this available remotely for experts so that they can make decisions on it and also update existing models on the fly or create new models, for example. Next slide, please. So with this, we're addressing the challenge in tunneling that has been defined around geological conditions ahead of the tunnel phase. And it kind of is the first step in this about bringing the geological conditions information to the experts, and the next steps would be about long-term documentation of geological conditions and also working out ways of predicting what is ahead of the tunnel phase. Next slide, please. And there's different parts of this that make this very innovative. Very important is bringing together, bridging the gap between the field or underground activities and the activities happening remotely or in the office, such as modeling. But here, it's very noteworthy to emphasize, it's important to emphasize that this, through the integration of this open source software that I've mentioned before, GemPy, that has been designed for an automation and a real-time geological modeling step, that we can have just-in-time availability of new data coming from the tunnel phase and update models when it is really needed. Next slide, please. So if we're looking for a partner, you see, as you've seen, we have our expertise in geodata and geological modeling. We are focused on software. So we would like to find someone who has complementary skills and expertise, especially in the field of tunneling and tunneling operations, somebody who knows about the hardware used in that, maybe also someone who can provide suitable scanning hardware for such environments, such as photogrammetry, but also partners who might have available like relevant data or also could give us access to relevant test sites. And that is it. Thank you very much for your attention. If you're interested in this, please feel free to contact us. If you have any questions, we'd also be here to answer them. Thanks.
Yes.
Thank you very much.
Yeah, thank you very much for your talk. And now, as you already mentioned, now the floor is open to all participants for questions. And we have a first question in the chat from Roland Timmermans, who asked, I think this goes into the direction of René. Innovative solutions often require very specific materials and components. A lead time of 9 months with current supply chain bottlenecks may be unfeasible for some products. So could this be a block payment of the voucher?
That's actually a very good question. It is indeed the case that the availability of raw materials and components is very difficult at this moment. What we basically have to do then is find a good balance between, let's say, the project dates that are relevant for our program, because we have, as a program, ultimate deadlines to complete the project, and the end dates of the projects is related to the end dates of the program. So first of all, it will depend on the moment that the application is done, whether we have some extra time in the end to, let's say, to discuss the possibilities of an elongation of the project. Now, if it's already known that some components or some raw materials may take a long lead time, then we can also look in, let's say, the flexibility in defining the deliverables. Because with defining the deliverables, there is a possibility to take into account what the impact of availability of raw materials of for a prototype, for example, will be. I know that's not a clear answer now. It's actually very good questions. And that's something that we have to think about. We have to take into consideration.
Okay, thank you. There's another question which might be also interesting for other participants, because we have a broad scope and also guests from the synchrotron in Hamburg, if I saw this right, from the DZ. What about the participation and the influence of partners far outside the region? Could they also have an impact or give an inspiration to the development of technologies?
That's a question for me, Henrik.
Yeah. Oh, sorry, René. Yeah, that's again for you. Yes.
So can you first repeat the first part of the question?
Yeah, it's a very short question. It's just participation from outside the region. I think what is meant is far outside the region. For example, Hamburg.
Yeah. Well, if you are located outside or far outside the extended region Meuse-Rhine, then it is possible to participate in a consortium. However, you will not be able to profit from the financial incentive that the voucher scheme has to offer. So only the eligible SMEs can profit from the voucher. And to build a consortium, there has to be at least 2 companies within that extended region from different sides of the border. And other companies outside can join.
A subcontract, or is it rather to be seen as business development?
Several possibilities. You can act as a partner, taking, let's say, risks and having costs in the project. However, these costs will not be eligible for a voucher. But it's also possible to attend as a subcontractor in the consortium. And in that possibility, you can, but not necessarily have to be, let's say, registered as an official partner in the project.
Okay, then Eric Vermeulen raised his hand, so he has a question. So again, just a small remark, type your questions into the chat or just raise your hand and then I will give you the word. So Eric.
Yeah, thank you very much. I may have missed the opportunity to be able to submit a project for this session. We are a company in the Netherlands that deliver surface particle measurement equipment. So we can measure contamination, so to measure whether surfaces are clean or contaminated or have cracks at microscale. And I'm interested for the specifications of the mirror. What is the level of cleanliness and contamination that is being targeted? Is that a question that fits here in this session?
I think in general, my partners may stop me, but I think in general we will have the technology workshops, and there we can go more into detail. I don't know if we have a fast answer right now. Ralf, you raised your hand as well. Do you have the answer?
Yeah, maybe it was not the idea that all the project ideas that you may have should already be in place today. We have given two examples just to show you how a project idea should look like. So just to introduce to you the basic idea, how a project idea should be constructed, how a partnership could be set up. So what is important, of course, not to have the idea today, but it is important that you take care of the deadlines that René Kessen mentioned in his presentation. So we have various calls for proposals. We have the 5-point structure for shaping a very first rough idea. And this is maybe the main entrance, that you, first of all, just sketch your idea in a one-pager using this 5-step approach, get in contact with your business developer in your region, and then get in a dialogue with him. And we, as partners, we will take over to look who could be potential complementary partners in the other parts of the cross-border region. So what I want to say is there is still enough time. The first deadline is 23rd of January, and the next deadline will be end of February. So you should make up your mind, that's clear. You should try to sketch your idea. You should provide us your wishes, which kind of partners you want to have. But yeah, the call is open since the 1st of December, and therefore you didn't lose anything so far.
Okay, that's great. And if I like to talk to somebody on the content level of the requirements for the overall objectives before submitting a one-pager, is that possible?
Yes, sure. We have, if you look at the vouchers section also on our website, we have contact persons in all the various regions. So if you are from the Dutch side, your contact person would be René Kessen. So if you have any question, please contact direct your regional business developer, who will help you further.
Okay, René, there I come. Thank you.
Okay, thank you very much. And I have the next question. I think it also goes to René's direction. If you already have a suitable partner, can you formulate a proposal directly?
That could be possible, but in any case, I would recommend to contact your regional partner first, just to make sure, absolutely sure, that the consortium fits within the requirements, that the project fits within the requirements, just to avoid any work that could perhaps lead to nothing. So contact your regional partner at any cost and discuss the ideas and possibilities.
Okay, further questions? Now here's a question. I think it goes to Achim. What output in the case of knowledge is expected by the Einstein telescope?
Well, it's scientific information, so we want to learn about the development of the universe, and how fast does it expand? How much matter is there in the universe? What is the nature of the dark matter? Is gravitational really as complicated as Einstein imagined it? These are the questions. There are the direct commercial use of the answers is far away. I don't know, have no idea whether this will lead one day to gravitational.
Maybe I can give a good example, Achim.
Yeah.
With the building of the CERN in Switzerland, when they have the large collision collider to study this antimaterial. There was one scientist who said, we have to able to share this data that we collect here with other scientists on the world. And then he invented something that we are using all today, which is the internet. So there are very, very nice applications that can lead from these scientific projects. So the internet was invented at CERN, Switzerland, and it was absolutely not the goal of CERN to invent this internet, but it became a nice invention that we use all today.
Yeah, the World Wide Web, to be more precise.
Yes, yes.
Yeah, but I would actually classify the results in twofold. What are the real scientific, the answers to the real scientific goals? And this is the tricky part where you have to think about those very long perspectives. And then there are what we call spin-offs. I know spin-offs is something else in business cases, but are technologies that have been developed along the projects. And the World Wide Web is a very good example of one of the technologies that was developed, as you mentioned, for internal communication in ever larger scientific collaborations, even before the LHC was still in the times of lab.
Okay, here's another question. I think it's a more general one, so maybe Ralf, you can give an answer. Is it possible to pre-discuss the relevance of the Einstein telescope with the science team? I think so. The relevance, the technological relevance, the relevance for the technologies for the Einstein telescope this way.
Yeah, well, there I think two questions pointing in this direction. First of all, that I already pointed out in my speech is that all questions around the technologies of Einstein telescope, especially the development needs, they really can be found in the section on our website ET Technologies, and there you have an ET online technology catalog. So there can you find for each of the relevant instrument and geology technology, you can find a sheet which has been written by the researchers already active in Einstein telescope technologies in the different projects. And in these sheets, you can find the development needs. And what is maybe answering the second question, there is not only a business development contact pointing out to the own project idea that I may want to develop, but there's also a contact to the researcher or to the researchers dealing with these issues. And if you have any need for discussion, if you have any questions concerning the technology, please feel free to get also direct in contact with the respective researcher or the researchers.
So do you have further questions? Now, if this is not the case, I think you can get into contact with us later on if there still emerge questions. Oh, wait, there's a budget for vouchers is 450,000 euros divided in vouchers of 25 or 50,000 euros. So 9 to 18 vouchers can hand out. Any chance of increasing the budget? Okay, this is a good question. René, is there any chance to increase the budget of single vouchers?
Let's hope. Let's hope. Let's hope. Yeah, if we see an opportunity that there is more funding available within the Interreg program, then we will surely look at the possibilities to expand this budget. Yes.
Yes, but we have to hope. We can't say this in general.
Yes,
we have
exactly.
to see.
There probably will be more programs within Interreg that be happy with more money.
Mm-hmm. Okay. Further questions? So if not, we would like to join you to a virtual networking. If you have still a bit time left, we have another solution called Wonder, and we would invite you to join a small networking. Maybe you can get into contact with the other participants. I just posted the link to this networking room, into the chat. So we would be happy to meet you there, maybe for further questions, or you can meet other participants for ideas. From my point, I thank you very much for your participation. If you have further questions in the future, just contact us, as Ralf already said. And we would be happy to get lots of applications from you. Ralf?
Yeah, I would like to thank you all for participating in our event, and I can all invite you, think on your project ideas, join our upcoming networking meetings, and be present in the new Einstein Telescope community here in this cross-border regions. Thank you very much, and bye-bye.
Thank you. Bye-bye.
Thank you. Bye.